Education is one of Brawijaya University's spaces that cannot be ignored. More than 170 departments in Brawijaya University compete to the highest contribution to this nation's education, and many have proved that they can produce competent generation for the nation. Electrical Engineering Department is the fourth established department in Engineering Faculty of Brawijaya University. Since it was built in 1978, it has contributed so much in producing high-quality alumnus with high experience in nurturing and teaching the nation's best youth for 40. Electrical Engineering Department has successfully become one of the highest quality and competent department in Brawijaya Universities based on the advance in science and technology as well as the nation's. This is proved by the facilities that support educational activities such as laboratories, comfortable reading rooms that encourage students to study and discuss with each other. Other than the available complete literature, we also provide a high-speed internet connections, which helps students to enrich their knowledge and enlarge the scope of teaching. Besides the supported facilities, the active cooperations with international institutions around the globe also give the chance to upgrade their perceptions, mobility, and knowledge to compete globally. This is proved by the high number of electrical engineering department students that are helped to continue their studies in other countries, so they have higher competency and experience. We believe that science does not have to be limited inside a class, because humans are created to continue building up the knowledge by exploring the surroundings from the magma in the earth beyond limited space outside. We believe the continuous innovations that are devised by the lecture team as well as student teams will make advancements and it will push us to become a high quality company nations in this global era. Created advancement will trigger many collaborations, so the continuous researchers will have bigger scale and tangle more groups of people, so it has the potential to create a bigger positive impact. With this commitment, the electrical engineering departments of Brawijaya universities become an ideal place to enrich knowledge and to improve oneself. From the moment we are born, we are always learning, either from self-experience or from the past ground knowledge. Perfecting self starts from a small step filled with confidence. With the commitment and self-confidence, electrical engineering departments of Brawijaya University has successfully incited many students' accomplishments in its history. Among them are becoming champions in regional and national robot competitions. Programmable logic control, and many more. We believe that intellectual can be proved by the emergence of national and international champions from the students. For example, Ilham Akbar, Electrical Engineering Department from the year of 2012, is the champions of International Business Plan Express in the United States of America. Hassan, a student from the year of 2014, Bagas Priyo Hadiwibowo, a student from the year of 2015, and Muhammad Dari Maulana have also incised many academic as well as non-academic achievements in the history of electrical engineering department. This became a motivation for the electrical engineering department students to continue their inventions by giving their best efforts, which thus continue the creation of useful innovation for the nation. Indonesia, with all of our strength and dedication, we have been, and we are ready to help you. The future is in the hands of a young generation, and us, Electrical Engineering Department of Engineering Faculty of Brawijaya University, have been and are ready to welcome and to nurture the young generations with our best. Education is one of Brawijaya University's faces that cannot be ignored. More than 170 departments in Brawijaya University compete to the highest contribution to this nation's education, and many have proved that they can produce competent generation for the nation. Electrical Engineering Department is the fourth established department in Engineering Faculty of Brawijaya University. Since it was built in 1978, it has contributed so much in producing high-quality alumnus with high experience in nurturing and teaching the nation's best youth for 40. Electrical Engineering's department has successfully become one of the highest quality and competent department in Brawijaya universities based on the advance in science and technology as well as the nation's best. This is proved by the facilities that support educational activities such as laboratories, comfortable reading rooms that encourage students to study and discuss with each other. Other than the available complete literatures, we also provide a high-speed internet connections, which helps students to enrich their knowledge and enlarge the scope of teaching activities. Besides the supportive facilities, the active cooperations with international institutions around the globe also gives the chance to upgrade their perceptions, mobility, and knowledge to compete globally. This is proved by the high number of electrical engineering department students that are helped to continue their studies in other countries, so they have higher competency and experience. We believe that science does not have to be limited inside a class, because humans are created to continue building up the knowledge by exploring the surroundings from the magma deep in the earth to the unlimited space outside. We believe the continuous innovations that are devised by the lecture teams as well as student teams will make advancements, and it will push us to become a high quality and competitive nations in this global era. The creative advancement will trigger many collaborations, so the continuous researches will have bigger scales and tangle more groups of people, so it has the potential to create a bigger positive effect. With this commitment, the electrical engineering departments of Rawija universities become an ideal place to enrich knowledge and to improve oneself. From the moment we learn, either from self-experience or from the passed down knowledge, perfecting self starts from a small step filled with confidence. With the commitment and self-confidence, electrical engineering departments of Rawija University has successfully incited many students' accomplishments in its history. Among them are becoming champions in regional and national robot competitions. Programmable logic control, and many more. Furthermore, we believe that in electrical engineering, a small step may become a big jump. This can be proved by the emergence of national and international champions from the students. For example, Ilham Akbar, electrical engineering department students from the year of 2012, is the champions of International Business Plan Esprit in United States of America. Hassan, a student from the year of 2014, Bagas Priyo Hadiwibowo, a student from the year of 2015, and Muhammad Dari Maulana have also incised many academic as well as non-academic achievements in the history of electrical engineering department. This became a motivation for the electrical engineering department students to continue their inventions by giving their best efforts, which thus continue the creation of useful innovation for the nation. Indonesia, with all of our strength and dedication, we have been and we are ready to help you. The future is in the hands of a young generation, and us, Electrical Engineering Department of Engineering Faculty of Brawijaya University, have been and are ready to welcome and to nurture the young generations with our best. innovation is one of Brawijaya University's faces that cannot be ignored. More than 170 departments in Brawijaya University compete to the highest contribution to this nation's education, and many have proved that they can produce competent generation for the nation. Electrical Engineering Department is the fourth established department in Engineering Faculty of Brawijaya University. Since it was built in 1978, it has contributed so much in producing high-quality alumnus with high experience in nurturing and teaching the nation's best youth for 40. Electrical Engineering's department has successfully become one of the highest quality and competent department in Georgia universities based on the advance in science and technology as well as the nation's best. This is proved by the facilities that support educational activities such as laboratories, comfortable reading rooms that encourage students to study and discuss with each other. Other than the available complete literatures, we also provide a high-speed internet connections, which helps students to enrich their knowledge and enlarge the scope of teaching activities. Besides the supportive facilities, the active cooperations with international institutions around the globe also gives the chance to upgrade their perceptions, mobility, and knowledge to compete globally. This is proved by the high number of electrical engineering department students that are helped to continue their studies in other countries, so they have higher competency and experience. We believe that science does not have to be limited inside a class, because humans are created to continue building up the knowledge by exploring the surroundings from the magma deep in the earth to the unlimited space outside. We believe the continuous innovations that are devised by the lecture teams as well as student teams will make advancements, and it will push us to become a high quality and competitive nations in this global era. The created advancement will trigger many collaborations, so the continuous researches will have bigger scales and tangle more groups of people, so it has the potential to create a bigger positive impact. With this commitment, the electrical engineering departments of Rawija universities become an ideal place to enrich knowledge and to improve oneself. From the moment we are born, we are always learning, either from self-experience or from the passed down knowledge. Perfecting self starts from a small step filled with confidence. With the commitment and self-confidence, electrical engineering departments of Rawija University has successfully incited many students' accomplishment and its history. Among them are becoming champions in regional and national robot competitions. Programmable logic control, and many more. Furthermore, we believe that in electrical engineering, a small step may become a big jump. This can be proved by the emergence of national and international champions from the students. For example, Ilham Akbar, electrical engineering department students from the year of 2012, is the champions of International Business Plan Express in the United States of America. Hassan, a student from the year of 2014, Bagas Priyo Hadiwibowo, a student from the year of 2015, and Muhammad Dari Maulana have also incised many academic as well as non-academic achievements in the history of electrical engineering department. This became a motivation for the electrical engineering department students to continue their inventions by giving their best efforts, which thus continue the creation of useful innovation nation, Indonesia. With all of our strength and dedication, we have been, and we are ready to help you. The future is in the hands of a young generation, and us, Electrical Engineering Department of Engineering Faculty of Brawijaya University, have been and are ready to welcome and to nurture the young generations with our best. Education is one of Brawijaya University's spaces cannot be ignored. More than 170 departments in Brawijaya University compete to give the highest contribution to this nation's education, and many have proved that they can produce competent generation for the nation. Electrical Engineering Department is the board-established department in Engineering Faculty of Brawijaya University. Since it was built in 1978, it has contributed so much in producing high-quality alumnus with high experience in lecturing and teaching the nation's best schools for 40. Electrical Engineering Department has successfully become one of the highest quality and competent department in Brawijaya universities based on the advance in science and technology as well as the nation's skills. This is proved by the facilities that support educational activities such as laboratories, comfortable reading rooms that encourage students to study and discuss with each other. Other than the available complete literatures, we also provide a high-speed internet connections, which helps students to enrich their knowledge and enlarge the scope of teaching activities. Besides the supportive facilities, the active cooperations with international institutions around the globe also gives the chance to upgrade their perceptions, mobility, and knowledge to compete globally. This is proved by the high number of electrical engineering department students that are helped to continue their studies in other countries, so they have higher competency and experience. We believe that science does not have to be limited inside a class, because humans are created to continue building up the knowledge by exploring the surroundings from the magma deep in the earth to the unlimited space outside. We believe the continuous innovations that are devised by the lecture teams as well as student teams will make advancements, and it will push us to become a high quality and competitive nations in this global era. Creative advancement will trigger many collaborations, so the continuous researches will have bigger scale and tackle more groups of people, so it has the potential to create a bigger positive impact. With this commitment, the electrical engineering departments of Brawijaya universities become an ideal place to enrich knowledge and to improve oneself. From the moment we are born, we are always learning, either from self-experience or from the passed down knowledge. Perfecting self starts from a small step filled with confidence. With the commitment and self-confidence, electrical engineering departments of Brawijaya University has successfully incited many students' accomplishments in its history. Among them are becoming champions in regional and national robot competitions. Programmable logic control, and many more. Furthermore, we believe that in electrical engineering, a small step may become a big jump. This can be proved by the emergence of national and international champions from the students. For example, Ilham Akbar, electrical engineering department students from the year of 2012, is the champions of International Business Plan Express in the United States of America. Hassan, a student from the year of 2014, Bagas Priyo Hadiwibowo, a student from the year of 2015, and Muhammad Dari Maulana have also incised many academic as well as non-academic achievements in the history of electrical engineering department. This became a motivation for the electrical engineering department students to continue their inventions by giving their best efforts, which thus continue the creation of useful innovation for the nation. Indonesia. With all of our strength and dedication, we have been, and we are ready to help you. The future is in the hands of a young generation, and us, Electrical Engineering Department of Engineering Faculty of Brawijaya University, have been and are ready to welcome and to nurture the young generations with our best.
Mm, mm, mm. Good morning, ladies and gentlemen, and may peace be upon you. And welcome to the 10 Electrical Power, Electronics, Communications, Controls, and Informatics Seminar, or EXIS 2020, which is held in Malang, East Java, Indonesia. The 10 EXIS is jointly organized by Universitas Brawijaya together with University Tun Hussein on Malaysia, also in partner with IEEE Indonesia section and IEEE Universitas Brawijaya student branch. The theme for the conference today is Powering Life in Society 5.0 through development of sustainable engineering and technology. Ladies and gentlemen, before we get started, first of all, allow me to introduce myself. My name is Adrian Adamindra Bayu, and I am the Master of Ceremony for the Axis today. The 10 Axis is a conference that brings together all researchers, scientists, engineers, and all experts in the area of electrical engineering to deliver sustainable engineering and technology solutions to make lives better in a society of 5.0 era. Before we proceed our activity today, first of all, we would like to express our sincere gratitude to Director of Electrical Power Institute from California Polytechnic State University, Profesor Taufik, Rector of Institut Teknologi 10 November Indonesia, Profesor Muhammad Asari, Associate Professor Wanur Zaswani Wan Zakaria from University Tun Hussein on Malaysia, and also the International Advisory Board from Indonesia, Malaysia, United States, Australia, and Taiwan. Honorable speakers, participants, delegates, ladies and gentlemen, as our welcome greetings, we would like to present to you a report speech from the General Chair of AXIS 2020. So please welcome Mr. Zainul Abidin, PhD. Mr. Zainul, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. May peace be upon you. It is our pleasure to welcome all participants to the 10th Electrical Power, Electronics, Communications, Controls, and Informatics Seminar AXIS 2020. It being held in Malang, East Java Province, Indonesia, from August 26 until 28, 2020. The AXIS 2020 is a virtual international conference organized by the Electrical Engineering Department, Faculty of Engineering, Universitas Brawijaya, in collaboration with University Tun Hussein on Malaysia. On behalf of the AXIS Committee, I would like to take this opportunity to address our sincere thanks to all the keynote speakers for having accepted our invitations to share their experience and expertise through the keynote speeches they deliver. Their expertise sharing will surely enrich the knowledge of and be greatly appreciated by the audience of the AXIS 2020. There are 64 research papers coming from 12 countries to be presented in parallel session programs. After following rigorous blind review processes with the rejection rate of more than 50%, the papers will proceed to the last checking and review before the final submission to IEEE Explore. Finally, we really wish that the conference will provide an opportunity for all participants to establish a scientific network and to discuss new ideas and developments in the converging technology and educations of electrical and electronics engineering in general. Wassalamualaikum warahmatullahi wabarakatuh. Welcome to AXIS 2020.
Thank you, Mr. Abidin, for
Assalamualaikum
the report speech.
warahmatullahi wabarakatuh.
Thank you, Mr. Abidin, for the report speech. For the next one, we would also like to show you the welcoming speech from the Dean of Engineering Faculty of Universitas Brawijaya. So please welcome Professor Pitoyo Triwono.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. First of all, on behalf of Faculty of Engineering, Universitas Brawijaya, I would like to express my appreciation to the organization of the 10th International Conference AXIS 2020 being held by the Electrical Engineering Department of Universitas Brawijaya in collaboration with University Tun Hussein on Malaysia. I also would like to extend my respectful regard and warm welcome to Professor Taufik from California Polytechnic State University, USA, and also Professor Dr. Muhammad Ashari, Rector of Institut Teknologi 10 November Indonesia, Associate Professor Dr. Wan Syahwani Wan Zakaria, University Tun Hussein on Malaysia. Great appreciation are generally delivered for their presence as the keynote speaker of this international conference. As we all know, the Axis 2020 become a biannual agenda as a part of scientific activity programs in the Faculty of Engineering to contribute to the creation of Brawijaya University as a world-class entrepreneur university. It is hoped that through the Axis 2020, the cooperation with various international industries, institutions, as well as our university could be much more improved and strengthened so that the scientific culture among the research and education institutions, as well as its link and map to industries, could bring out and welfare of the Indonesian and international society and humanity in general. Finally, although this is a virtual conference, I wish all participants an enjoyable and also productive conference program. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much.
Thank you, Professor Pitoyo Triwono, for the welcoming speech. Ladies and gentlemen, now we are coming to the main program, the keynote speech, that will be led by our moderator, Mr. Waru Juriatno, MT. First of all, allow me to introduce our moderator. Mr. Waru Juriatno was born in Pasuruan, Indonesia in 1969. He received his bachelor's degree from Universitas Brawijaya in 1995 and received his master's degree from Universitas Gajah Mada in 2007. Now, he is a lecturer at Department of Electrical Engineering of Universitas Brawijaya. He is also the member of Digital System Laboratory of Universitas Brawijaya. He is also highly interested in voltage generator circuits and image processing. Ladies and gentlemen, please join me in welcoming our moderator, Mr. Waru Juriatno, MT. Mr. Waru, the time is yours.
Thank you to the MC. I will handle this session. Okay, thank you to the MC. I will handle this session from now on. Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, good morning, and may God bless you all. This morning we have three speakers. I will mention they are all. The first speaker is Professor Taufik, the director of Electric Power Institute from California Polytechnic State University, United States. And the second speaker is Professor Dr. Insinyur Muhammad Asari M.Eng. He is the rector of Institut Teknologi 10 November Indonesia. Our third speaker is Associate Professor Dr. Wan Nur Saswani Wan Zakaria. She is from University Tun Hussein On, Malaysia. First, I will read the short bio of Professor Dr. Taufik. Professor Taufik received the bachelor degree from electrical engineering at Northern Arizona University in 1993. And then he received the master degree in electrical engineering from University of Illinois at Chicago in 1995. Doctor of Engineering in Electrical Engineering received from Cleveland State University at 1999. And now Professor Taufik senior member of IEEE, Institute of Electrical and Electronics Engineer. He also is a member of American Society of Engineering Education, or ASEE. And from 2009 until present, Professor Taufik became a professor of electrical engineering in Cal Poly State University of California, United States. Okay, ladies and gentlemen, here we present Professor Taufik.
Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for the very nice introduction. I would like to thank the conference committee for inviting me to this conference, and as well as to give me the opportunity to present my views or share my views on Society 5.0 as it related to net zero energy building. And so therefore, today my presentation is going to be entitled Advancing Electrical System Technologies to Achieve Net Zero Energy Building. Again, my name is Taufik. I'm currently a faculty member in the Electrical Engineering Department at Cal Poly State University. And before I proceed with my presentation, I'd like to talk a little bit about the university. But just briefly, Cal Poly is founded in 1901. The name back then was California Polytechnic School before it was changed to California State Polytechnic College in 1947 until eventually it changed to Cal Poly State University or California Polytechnic State University in 1972. So here's the outline of my presentations, and I will try to be brief on my presentation with the hope that we can have more time for question and answers. But above all, my hope is that after I'm done with my presentation, I could trigger some interest among all of you in following up on the ideas or examples that I'll be presenting within the presentation, and hopefully in the future we can establish some kind of a research collaboration. So that is the main goal that I have for this presentation. So we'll see, right? Now let's start with the background of my presentation. When I was contacted by the committees, I was informed that the theme of the conference would be powering life in Society 5.0 through development of sustainable engineering and technology. So if you look at the theme right there, I was thinking there are three main components of the theme. The first one, and I actually marked them red in that on the slide, if you can see that. The three main components of the theme. The first one is powering life. Second one is Society 5.0. And then finally, sustainable engineering technology. And so thinking, what kind of topic would actually fit into these three major components of the conference theme. In addition to that, as you may know, my background is in power electronics. And so I was also thinking, hey, what could I pick as a topic that could encompass all four components, namely powering of the conference theme, Society 5.0, sustainable, given my background in power electronics. So after thinking about this, I came up with a topic that I would say would be a good intersections of all four components that you see on the slide, and that would be the net zero energy building, right? So let's start with what is Society 5.0. So just briefly, was raised by the Japanese government in 2016. It represents the fifth form of society following hunting, farming, industry, and information. You can see the diagram on the right that Society 5.0 represents also a super smart society where has three different objectives, if you will. The first one is to resolve various social challenges by incorporating innovations into society. Number two, provide goods and services at an appointed time and remove inconveniences caused by age, gender, region, and language differences. And lastly, to provide highly integrated material and information. And so, again, I'm hoping that by the end of my presentation, you'll understand why is it that net zero energy building can actually help achieve these three objectives. All right. So then, what is a net zero energy building, or for short, NZEB? So NREL stands for National Renewable Energy Lab in the US, defines it as a residential or commercial building with greatly reduced energy needs. So in such a building, efficiency gains have been made such that balance of energy needs can be supplied with renewable energy technologies. Right? There are actually 4 different classes that they define, starting from the highest class, which is class A, down to the lowest, which is class D. I don't want to go into details on this, but basically it evaluates or assesses how much offset of the energy being used or consumed by the house or by the building by or from renewable energy within its own footprint, right? Basically the footprint of the building or the house, or kind of a mix between on-site renewables and renewables provided by an outside source. All right, so how do we create a zero energy building? There are 2 different steps. The first one is when you construct, design, or use, right, energy. So construct the building, design the building, as well as when you use the energy within the building or a house. Right? So that's step 1, and step 2 is to address remaining needs. So once we know that the building itself will consume some energy, then the next thing would be how we can actually offset the remaining energy, the remaining needs of energy of this building or house from either on-site renewable energy generations or someplace else, right? Just outside of the footprint. So what I would like you to see here from this slide is I would like to emphasize 3 different things here indicated by the red arrows. Is that I'd like to address the 3 things that would be related to this presentation. Number 1 is efficient building construction. So you'll see that I'll be providing some examples on that one, as well as efficient systems and appliances, also some examples on that one. And finally, on the renewable energy source side, I will also provide an example on the solar, how to advance the technology related to solar panels. Here's a picture of a net zero building, a net zero energy building. As you can see, there's a lot of components that that we can try to address, right? In terms of technology, these are different components that we can actually try to improve, right? To advance. Again, I would like to emphasize 4 different things here that would relate to my presentation today. The first one is related to efficient lighting. Second one relates to energy management of the house. And third one, photovoltaic panels. And lastly, high performance windows as well as doors. And I would like to emphasize 4 different things here that would relate to my presentation today. The first one is related to efficient lighting. Second one relates to energy management of the house. And third one, photovoltaic panels. And lastly, high performance windows as well as doors. Right. Let's go over the first example that I have from the previous slide that relates to smart and efficient lighting. So to me, LED is a true game changer in this case. As you can see, the LED technology has been around for a while. However, when it comes to lighting, it took off, just recently, relatively speaking. Right? And when it comes to lighting, through LED technology, our lighting now can become very efficient. Not only that, because it is solid state control lighting, therefore our lighting nowadays could be more versatile, right? Because we can actually control it more than what we had before with the previous technologies for lightings, as well as in terms of the level of connectivity, right? So nowadays, this product, the picture that you see on the lower left, right there, it's a product that's been available for some time. Is that we can actually use our smartphone, for example, to control the brightness of our light. Right? Of course, these are LED lights. Not only that, we can also control the color of the light, right? So you can change the color of the light as well as the brightness level of the light. Now, another thing is that with LED technology, you could still have the opportunities to look into ways to make it more efficient, the way we use LED light itself, right? So if you look at the picture on the right, this is something that we've done at Cal Poly, for example, that where we design and built what we call adaptive lighting. So it senses the ambient lighting, and then then they would decide, okay, what kind of a brightness should the LED give out based on the surrounding ambient lighting. So in addition to improving how we use LEDs, like the one I showed earlier, we could also try to improve the circuitry that provides the energy to these LEDs. So in other words, LED drivers. And we can still have, there's still big opportunities for us to be able to improve efficiency of these LED drivers, improving quality, as well as size and cost. Some of the examples of improving quality involve, for example, having LED drivers that can produce close to unity power factor while reducing flicker. And another thing is that nowadays, as you may know, LED drivers use mostly DC to DC converters, and they are switching converter. So when you use switching converter, they're inductor-based typically. And so some people don't like to have magnetic components in their circuit because they're relatively big and as well as expensive. So therefore, there's some ideas going around on how to actually avoid using or prevent using inductor when we drive LEDs. And so one example of that, if you look at the bottom left picture, that's one thing that we've done at Cal Poly. It's called direct AC LED driver. So instead of using DC to DC converter, we use linear electronics. You can see from the circuit there, or the green PCB there, or the green board there, that there is no inductor, right? So inductorless converter for LED driver, right? So that could be done, and we've done it at Cal Poly. Again, it's called direct AC LED driver. In the middle, that's not from Cal Poly, that's from another university, I don't recall from where. That one is also interesting because it's using microprocessors to be able to control specific numbers of LEDs, right, or sequence of LEDs to turn it on and off. Right? And then on the bottom right, another project that we attempted at Cal Poly. So again, this is to reduce cost by avoiding the use of inductor. So from rectifier, we clamp it, and then from the clamping circuit, we use LDOs, which stands for low dropout regulators, and then from then on, you can drive the LEDs. So as you can see, there's no switching regulator there. And again, this is an idea that's coming from Manhattan Group project, if you're interested. All right, next is going to be on the PV panels portion of the house, basically on the renewable energy source of the NZB. So what can we do on these sites? And as an electrical engineer, my interest is on, of course, the energy conversion portion of it. And so this is another idea that came out of Manhattan 2 project, where they have this idea of having a cell-based energy controller rather than a centralized or centralized or solar panel based converter. So traditionally, right, if you have solar panels such as this one right there, you look at the picture on the bottom left, you have a big solar panel. Typically, for every single solar panel, you will have a converter for itself, or maybe you have series of solar panels connected into one single converter, right? You could do that as well. But what Manhattan 2 project came up with is that what if we could do the converter on the cell base level? So if you look at the solar panel here, the solar panel consists of cells, right? Different cells or a certain number of cells. What if we have somehow controller that's going to be embedded on a single cell, right? So imagine if you look at this one cell, and behind that cell we have a converter, like small, of course, a small converter that will directly convert the DC from the solar cell straight into the AC sine wave, right? So of course, this is, to me, this is a good idea to do, because then if you can have this kind of technology, then we have so much, versatility and flexibility in terms of, as well as reliability in terms of providing power from solar panels, right? So that's one way to do it, is to have some kind of a power converter that directly convert from DC to a sine wave, right? And on the right hand side right here, similar, you can see that we have a controller embedded into every cell, right, behind the cell. But this one, the difference between the two is that on the left, you are using switching converter, but on the right, you are using pure switches. So there's no power converter there. There's just switching, right? And what do I mean by that is that imagine if every single cell is connected to a switch, right? So then depending on what kind of level of AC output you want to get, then you can connect different cells, right, through these switches to create or produce an AC, right? So of course the impact of that would be that the AC output will have some kind of a step waveforms, just like that, right? So you see the steps. So depending on how many cells you are connecting, that would give you the amount of voltage that you get from each of these steps. So basically you are creating a sine wave by producing multiple steps. Right? On the energy management and distribution side of the building or the house, this is one of my favorite research topic to do, because it's very close to what I've done since 2010, which is the DC house project. And so this is where what I envision going to happen in the future, or in future homes, is that I project that in the future our homes will be running two different electrical systems. First one is AC, the other one is DC, right? And so the AC electrical systems would run mostly the big loads, such as air conditioning, washing machines, refrigerator, what have you. And then the DC electrical systems would provide power for smaller loads, but there are many, right? Such as lightings, charging your portable devices, charging your laptops, and so on and so forth, right? And so the idea of having hybrid electrical systems to a residential unit or a building is what I've been developing at Cal Poly as well. in order to do that, we're going to have some kind of a hybrid power controller. And we already designed that at Cal Poly. We call that, MISO converter, which is able to combine energy from different sources. So if you look at the left portion of the diagram, you can see we have one source coming from the solar panel, which is a DC source. And then we could also incorporate a battery. And then another source that's coming from utility, or in Indonesia, we use energy from PLN. And so all of this energy could be combined or converged into the single house that runs into two different electrical systems, AC electrical system with its own wiring, and DC electrical system with its own wiring as well. As I said earlier, the AC goes to the AC loads, DC goes to the DC loads. And to me, this would help facilitate the development of smart house to achieve the net zero energy building. This last example shows another way for us to leverage our technology, current technology, again to support the movement toward Society 5.0, right, related to NZB. Right? So imagine if we have a smart window or smart blinds covering of the windows. This is not only a function of lighting. We could also incorporate, for example, temperature in addition to ambient lighting. You could also utilize, sensors for temperature, ambient temperature, right? To again to achieve this energy efficient house, right? So again, what we've done at Cal Poly, we are just looking at controlling this or producing these smart blinds based on ambient lighting. So what if we combine these, add more parameters into these smart blinds so that the use of the energy in the house becomes even more efficient. Right? So again, a lot of things that you can do here, not just for windows, you can also do it for other things in the house, right? All right, so that concludes the examples that I have for this presentation. So to summarize, I believe that NZB, or net zero energy building, is a manifestation of Society 5.0. Again, because in order for us to achieve or accomplish NZB, we would have to have all these necessary technologies to be able to achieve energy efficiency in the building, right? And that is the essence of Society 5.0, right? How do you incorporate these technologies to be able to reduce our energy consumptions in the future, right? And then in terms of electrical systems, electrical engineering, part of these NZB, as you've seen in my examples, there are a lot of things that we can do as an electrical engineer to develop these technologies, right? And incorporating smart technologies to achieve, again, NZB, while seamlessly supporting even more smart technologies to move towards Society 5.0. Again, as I said earlier, I've provided several examples to show a glimpse of challenges and opportunities for future electrical engineers. And again, as I mentioned in the beginning of my presentation, it is my hope that after this presentation, you'll become interested in these areas, and hopefully we can follow up with some research collaboration maybe between you and myself at Cal Poly, right? And thank you very much for your attention. And at this point, I would like to entertain some questions if you have any. Thank you.
Okay, thank you for Professor Taufik for the interesting speech. Okay, I will open the Q&A session. please all attendee or all participants to send the question by writing using the chat bot or connect directly to Mr. Taufik. Okay, it's look like okay, Professor Taufik, perhaps is there any question from the attendee or participant to Professor Taufik? Okay, perhaps I will ask myself to Professor Taufik. I will ask about HVAC. The equipment that consume energy the most in our house usually heater or air conditioning unit. I do not see discussion about heater and air conditioning unit preservation of energy. Perhaps Professor Taufik have as idea about how to conserve energy in air conditioning unit.
Can you hear me? Hello, can you hear me?
Okay, I can hear you.
Okay, great. I think if I'm not mistaken, you asked about what kind of ways we can save energy from the heating portion of the loads, right? To me, there are at least a couple of ways we could do this. Number one, through the hardware of the system itself. That could be coming from, for example, motor technology. Right? Nowadays, we use, for example, most commonly induction motors, but as we know, motor technologies are also progressing to be more efficient. So we could also use those, efficient motor technology, right? Like brushless, DC motor, and or alike. And so that's one way through the hardware of the system itself. The other part of the hardware will be the energy conversion of it, right? So basically, once you are operating this system, then how do you make it more efficient? So you can basically do different type of motor controllers, semiconductors, right? For example, we could now use or implement technologies such as GaN or silicon carbide type of technology. And that again would improve the efficiency. That's one side of it. The other side, of course, we could also implement smart technologies. Right? How do you turn on? How do you operate? How do you manage the operation of these heating? Not just heating; it's also air conditioning, right? So just like smart lighting, I think it's similar. You can incorporate different type of sensors to be able to operate this system in a smarter way, right? You can do, for example, based on temperature. That's obviously what's been done. Based on maybe occupancy of the building. That's another way to improve, and so on and so forth. So to me, and then behind the control systems, you got all of these, intelligent control systems, which is not part of my background, but you have different type of algorithms you can run and so on and so forth. So I think that's a big area by itself to actually improve the big AC loads such as air conditioning as well as heaters. I hope that answers your questions.
Okay, thank you, Professor Taufik. One question from the participant. I will read it. If we have existing building, how to apply the concept or application of net zero energy building in the existing building? Thank you. That is the question.
Yeah, so a net zero energy building strongly relates to how you be able to offset energy consumptions, right, based on what you can generate yourself, right? And so when it comes to consumption, right, when you hear the term consumptions, right away you talk about, from engineering point of view, of course, that would strongly relate to how efficient you're consuming your energy, right? Because there are infinite ways of using your energy. You can use it um, just anytime you want, or you want to manage your energy usage wisely, right? And so when it comes to efficiency of the net zero energy building, I think that is a very strong or very a major component in a net zero energy building, because that would determine how much you actually consume energy, right? That hopefully could be offset by, let's say, solar panels that are sitting on the rooftop, right? So if it can become more efficient, let's say before the system is efficient, let's just say, before the building is efficient, let's say you're consuming 1,000 watts, right, at a certain time. But then when it's efficient, right, you can actually consume more, can consume more, right, with less supply of energy, right? So then, or in other words, you can actually consume less with the same amount of source that you need. Right? So that to me is really directly tied to how efficient your system should be in order to accomplish net zero energy building. So very important component of NZV.
Okay, thank you, Mr. Taufik. The time is up. I'm really sorry about that, but
That's
we
okay.
must
Thank you.
go to the second keynote speaker. And to the all participants, if you have still any question for Professor Taufik, please contact him directly using email, or if you have the WhatsApp contact, please contact him directly. Thank you. Okay, ladies and gentlemen, we go to the second keynote speaker. Our second keynote speaker is Professor Dr. Engineer Muhammad Asari, M.Eng. He is the present rector of Institut Teknologi 10 November Indonesia. Professor Muhammad Asari will give speech titled Smart Technology for Quality Enhancement of Green Energy. Professor Asari was born in Sidoarjo 1965. He received the Bachelor of Science degree in Electrical Engineering from Institut Teknologi 10 November Surabaya in 1989. And then received the Master of Science degree in Electrical Engineering from Curtin University, Australia in 1997. And then in 2002, he received the Doctor of Engineering in Electrical Engineering from Curtin University, Australia. Ladies and gentlemen, here is Professor Dr. Engineer Muhammad Asari, M.Eng. Please, Professor Asari.
Hello, good morning. Can you hear me, Pak?
Okay, I can hear you clearly.
Okay, bye. Thank you very much. Thank you for the time given to me. And I would like to share my content, yeah, before I present the presentation. Let me try to share. Yeah. So has it come up the presentation now? Pak? Can you see the presentation file?
Yeah, okay.
Okay.
Okay, you can see it.
All right. Okay. Thank you very much. First of all, I would like to thanks and congratulations for Department of Electrical Engineering and University of Brawijaya for conducting this seminar, EECCIS, which is the 10th years. It's quite long seminars, I think, yeah. And it would be very good for electricals practitioner, researcher come together to share the idea. So I would like also to say hello to Professor Taufik. Selamat pagi, Pak Taufik. Good morning. We met again, Professor Taufik. We have a collaboration with our institution, Institut Teknologi Surabaya, Institut Teknologi 10 November Surabaya, that Professor Taufik also joined with us to supervise PhD student in Surabaya. Even we met in virtual. Also, I would like to say hello to Associate Professor Dr. Wan Nursaswani. I think we met some times ago in UHTM, yeah, in Malaysia. Okay, ladies and gentlemen. First, I would like to here is that I would like to talk this morning in this conference. First, introduction, especially introduction to our campus for ITS, and then the second one is energy demand and planning, especially for Indonesian government. And the third one is energy global issues and smart technology for green electricity. Okay, now ITS. We are now University of Brawijaya in Malang. It is around 90 kilometers on Surabaya. Surabaya in the south, in the northern part of Malang. Yeah. ITS is similar with University of Brawijaya, but located in different city. Surabaya, we have a monument, we have a pahlawan monument, hero of monument, and then we have a Suramadu Bridge. So everybody, please come to Surabaya and see all this landmark, including ITS. Ladies and gentlemen, all participants, all distinguished participants and guests, also senior leaders of Brawijaya University. This is a brief of ITES structure of organization. Now we have 20,000 students. This is quite small compared to UB, Brawijaya University, which is more than 60,000. In Surabaya, ITS has 20,000 student body. We have also a small size compared to Brawijaya. ITS has less than 1,000 faculty members. ITS, we have 7 faculties, 10 research center, 5 study centers. Study centers means having collaboration for society. And we have also 4 innovation center. All this faculty, research center, everything here, we design in line with Industrial Revolution 4.0. So digital ecosystem. Faculties, we have artificial intelligence, especially in information and electrical engineering. Big data, we have a science and analytical big data faculty. Internet of Things, we have also robotic and also everything, yeah. And then here is the our society. We have digital economy society, we have an intelligent automation society, and industry, we have smart life society. So this is very in line with the topic of the seminars today. And next, this is the faculty in ITS, and this is the research center in ITS. We have 10 manufacturing, we have a sustainable energy, artificial intelligence and healthcare, advanced material and nanotechnology, Internet of Things and everything. Yeah, we have 10 research center. We have a 5 study center relating to the society, like a regional development and empowerment. Yeah, applied technology, halal research study center, sustainable development goals research center, public policy, industry, and business research center. So we have 5 research center. And also we have 4 innovation center. Innovation center, or probably our audience very familiar with technology park or tech park. Here in ITS, we have innovation center. We have 4 clusters: automotive, ICT, robotic, creative industry, and maritime. So in automotive, ITS has a present electric scooter or electric motorbike. We call it Kesits. And we have also, during this pandemic, present a product of robot we call Risa. This is a hospital robot assistant for COVID-19, already implemented and already used in many hospitals in Surabaya, Malang, also in Jakarta. Creative industry cluster, we have a design of light rail transit and also maritime. Yeah. Okay, now this is the second topic that I would like to discuss this morning, which is a global issue of energy. Ladies and gentlemen, or distinguished audience and senior leaders of University Brawijaya, this is the world of energy supply or energy sources during a century ago, which is at 1980, hydro energy, nuclear is quite small, oil is a big portion, and coal is still the biggest one. And then now, I think this is in 2018, the combination of energy mix little bit different because there is wind and solar technology comes to our energy supply. And then it is predicted by Bloomberg that by 2050, by Bloomberg 2050, the energy mix will be fossil fuel by 2020 is decreasing to 31%. And then nuclear energy still exists, but renewable energy have a big portion to our energy mix in the world. It will be 62% energy mix from renewable energy by 2050. So the global power demand grew by 69% from today's in 2018. And then the composition in 2050 of 62%, the combination of solar and wind and others is around 48%, but the rest is from the other geothermal and hydro. Okay, participant and all distinguished speakers. And then this is the solar panel price estimated drops to 85% by 2050 from today's 2018. So within around 30 years, the price of wind turbine will drops to 49%. And the battery also, today's price is quite expensive, but by 2050, the price will drop up to 85%. So become very cheap in 2050. Okay, this is the energy meet in Indonesia during COVID-19. So we can see here, the blue line is fuel consumption, especially for transportation. Yeah. So this is the normal before COVID. And then by April 2020, last April, the fuel consumption reached 16%. And after lockdown in many places separately, like in Jakarta, in East Java, in middle of Java, which has a different time, but that is the reality of partial lockdown. And then it breaks to reduce the fuel consumption national domestic up to 40%, minus 40%. The same thing, this is the curve for electricity. The electricity demand for industry also drops around 40% during the COVID, during April to June, and then become increase again gradually. But electricity for residential demand slightly increase, but not much. Yeah, cannot cover the drops of electricity for energy demand, for industry demand. So every industry now during COVID-19 suffer from many things, including low demand of electricity. And how the Indonesian government to try to meet the energy demand. Indonesian government, we have a domestic exploration. It's around 800,000 barrel per day. And then because it is not enough, Indonesian government still import crude oil. And then domestically, we have refinery. From exploration, put it in refinery, but the capacity of refinery, it's not enough to cover all the exploration. That's why Indonesian government also import the fuel. So both crude oil and fuel to be imported for Indonesian demand. And from the other side, the electricity, yeah. The electricity, this is the reality in 2018 that the electricity is made by batu bara, coal, is around 59%, by gas 22%, and by oil 6%. But in addition, by renewable energy, especially hydro and geothermal, is around 13%. This is the condition in 2018 for electricity demand, electricity installed power. And then for the fuel, Indonesian government to develop a biofuel, which is already mixed to the diesel fuel with previously 5% of biofuel, and then consisting of around 20% of biofuel. Also in electricity, Indonesian government to try to mix up, to add the renewable energy sources to the grid system. Here is the planning of Indonesian government that the position in 2015, the energy mix is 5%. The target in 2025 is 23%. So we can imagine from 5 to 23%. But in 2050, it is estimated, or the target for any renewable energy penetration to the mixed energy become 31%. So it's quite many opportunity for researcher, for business, for government, try to implement from 5% to 23% to 31% for renewable energy mix in our global energy demand, which is 31% consists of bioenergy, hydro, geothermal, solar, and others 30%. Okay, so now we come to the next issues. So introduction, energy demand and planning, and the third one here is global energy issues. Ladies and gentlemen, and distinguished speakers and senior leaders, there are three global issues for the energy. The first one is decarbonization. The second one is digital intelligence. And the third one is decentralization. So this is three big issues of energy global. Decarbonization, what is decarbonization? Decarbonization is the issue in the global that we would like to reduce the emission. So we try to reduce the electricity power plant sourced by coal. And all government in the world try to add more renewable energy to the electricity system. And then for decarbonization, everybody knows now that electric vehicles become very famous in our society. ITS already launched electric vehicle for scooter type, for car type, bus type, etc. But this is a prototype, result of a prototype of research. The second thing, the energy global, is digital intelligence. This is, I would like to say that digital intelligence here only correlate in our electricity system, yeah, but not all this one. All industry now moving to digital intelligence. Not only digital, not only intelligent, but also digital. Yeah? But also intelligent. Not only automation, but also intelligent automation. Yeah? So here we'll know about smart loads. We will know about smart energy. We will apply smart management. It means that load is controlled by intelligent automation. Energy, also energy sources, how to come up, how to turn on, turn off, is fully controlled by intelligent automation. And then the third issue is decentralization. I think just now Professor Taufik already mentioned decentralization of power system, distributed generation, etc. This is of global issues.
Pardon me, Professor, we have 1 minute remaining.
Okay. Oh, I think it's already 10 minutes. Okay. This is energy global issues. We know combustion engine car will be phasing out from Europe by 2025. Yeah. And then here is the position of Indonesia electricity involving renewable energy. That we have 5 megawatt peak solar in NTT. We have a grid connected wind farm in Sulawesi. And it will change our power system. because renewable energy comes to high voltage and also lower voltage, medium and lower. And then our system will be, in the next stage, will be complex grid system. It means that it's quite different. The type of load, the type of supply power plant is quite different. Like here, we have have multi-energy system microgrid. We will have a charging station for electric vehicle in many places and a big capacity totally, and comes to our grid system. And it needs totally infrastructure of smart technology. So we have to change our grid system from traditional infrastructure. We put more to intelligent infrastructure. And then we have a quite field of development, like converter battery system, renewable energy smart, smart plant, smart distributed sources, smart distribution network, etc. So the prerequisite is we have to change our infrastructure to be intelligent infrastructure. And then we can do some research. We also can have prediction or adaptation or preparation before this technology comes reality in our daily life for, I think, not so long. In the near future, we have to do this. And then this is the research that we can do regarding renewable energy, smart, and then power quality, and also a smart distribution network. Yeah. So using this kind of smart technology, we can get better efficiency, we can get better quality for daily life. And I need another 2 minutes to, this is the yes, we brought it to Indonesia regarding intelligent car. We developed iCar, intelligent car. We just call the car by our phone, and then it comes without driver or driverless. Choose the place we want to stop, and then this driverless car will accompany us around the campus. So we call it intelligent car, presented by students of IDS. And we will use this car for shuttle inside the campus. I think that's all my presentation. Thank you very much.
Okay, thank you very much for nice presentation, Professor Muhammad Asari. Now we have a Q&A session. We open one question to all participants, please. If you have one question for Professor Muhammad Asari. Okay, this is question from Bapak Muhammad Rusli. He asks about, what do you think about Indonesia? Is Indonesia ready to follow the global issue? Okay, please, your opinion, Professor Muhammad Asari.
Yeah. So thank you very much for the question. Indonesia, gimana ini cara melepas? Oh, ini stop sharing ya. Okay. So thank you very much for the question. Indonesia is part of global country, so we have to join and we have to adapt our society to be following the global. So that's why, even ready or not, we have to follow the technology development in the world. So I think now our government, Indonesia government, try to prepare for coming to a global high technology for Indonesia, like the electricity. Many renewable energy sources comes to our grid. Many renewable energy PV farm was built in some location in part of Indonesia, and also wind turbine also installed in several parts in Indonesia. I think this is a preparation by the government for us to join in the global high technology nearly. I think that's all. Thank you.
Okay, thank you for the answer, Professor Muhammad Asari. Unfortunately, our time for the second keynote speaker is up. Okay, we now go to the third keynote speaker. Here we will present Associate Professor Dr. Wan Nur Saswani Wan Zakaria from University Tun Hussein on. Professor Wan Nur Saswani will give a presentation titled Deep Learning in Medical Image Analysis and Computer-Aided Diagnosis. I will read a short bio of Professor Wan Nur Saswani. Professor Wan Nur Saswani received a bachelor degree in mechanical and electronic engineering from Chiba University in 2007. And then she received a master degree in mechatronic engineering from Newcastle University, UK in 2008. In 2012, from Newcastle University, Professor Wan Nur Saswani received the Doctor of Philosophy in Mechanical Engineering. Recently, she became the senior member of Institute of Electrical and Electronics Engineers of IEEE. To preserve the time, now we will hear the presentation from Professor Wan Nur Saswani.
Hi, good day everyone. Thank you for inviting me for the keynote speech for today. It is my great pleasure to talk to you about deep learning in medical imaging and computer-aided diagnosis. Today, I will talk about one of our research group project on ischemic stroke detection, where it was our collaboration study between UTHM and UKM Medical Center. So the content of my talk will be as follows. First, I will discuss some brief introduction to the ischemic stroke, followed by the computer-aided system in stroke diagnosis. Next, I will explain in detail about our deep learning approach to stroke diagnostic algorithm. And in addition, I show our proposed CAD system and end my presentation today with the achievement and related issue toward the deep learning approach in development of CAD system. So I think everybody are familiar with stroke disease. Stroke disease is ranked as the second leading cause of death and a major cause of disability worldwide. Stroke occur if there is an interruption of blood flow in the brain. And generally, there are two types of stroke, either ischemic or hemorrhagic. Generally, this ischemic stroke account for about 80% of all cases, while hemorrhagic stroke account for 20% of the cases. So how can stroke can be diagnosed and evaluated? Okay, so there are two brain imaging modalities to diagnose stroke, which are CT scan and MRI scan. CT scan is particularly useful over MRI in the emergency setting and suitable to monitor stroke patient in unstable phase. Thus, CT scan is often considered as the first-line measurement in clinical practice of stroke diagnosis, since MRI is less widely available, primarily in rural hospital or stroke center. Okay, let me discuss about computer-aided diagnosis in stroke diagnosis in details. Technically, there are various techniques applied in the development of CAD to classify normal or ischemic CT slices using traditional machine learning-based method. Typically, this method begin with a pre-processing, followed by segmentation, feature extraction, and classification steps to segregate whether the slice is normal or abnormal. Okay, so contrary to classical machine learning method, the modern CAD that apply deep learning is capable to directly learn the features of an image without a handcrafted feature extraction step. Okay? So basically, deep learning is actually the extension of traditional neural network that implement more network into the architecture. Okay, until now, various deep learning algorithms have been successfully developed and studied in various applications. And among of these algorithms, convolutional neural network or CNN is currently the most popular method in classifying high-dimensional data that implement a convolution operation of matrix multiplication. Okay, as you can see here, CNN is typically composed of 3 layers, which are convolutional layer and pooling layer that focus on the feature extraction, and fully connected layer that focus on classification. As computer-aided diagnosis has been widely developed in medical image analysis, here we can see how CAD system can be integrated to support the standard review of medical diagnosis primarily in radiology. Okay, as you can see here, there are various commercial CAD systems that have been introduced to assist radiologists and medical practitioners. Additionally, these available advanced systems mainly aim to facilitate the diagnostic procedure in rapid, efficient, and accurate way. However, as you can see here, all these available CAD system only focus on the anterior part of brain, and the diagnosis in posterior region are very limited. Therefore, we come out with 2 key questions. The first key question is, can we combine multiple image enhancement method and image task on one step with assistance from deep learning? And the second key question, can we use deep learning to define posterior fossa region for diagnosis in a more reproducible and accurate way, and eventually assist clinical support in decision-making process? And the answer is yes. With deep learning, we can have reproducible and accurate diagnostic procedure, we can enhance image interpretation, and we can enable more widespread use by those with less training. So before we go further, let's discuss some issues and challenges that have been faced in ischemic posterior fossa stroke detection. As you can see here, posterior part is the deepest part of brain that is responsible for balance and coordinated movement. The diagnosis is very hard because it solely depends on the manual identification of CT scan, where this procedure is very time consuming and highly depends on the experience of radiology. Okay, and in the same time, it can be adversely affected by the high intra and inter-observer variability, and it can take up to almost a day from brain changes to appear on CT scan due to existence of beam hardening artifact due to the amount of bone in PF region. And in the same time, we face the time delay for the stroke to emerge on the neuroimaging. Therefore, we propose a deep learning approach for development of diagnostic algorithm to detect ischemic stroke, particularly in posterior fossa region. So here, our goal is to develop an automated approach to detect and quantitate infarction in posterior fossa region. Okay, as you can see here, this is the general idea of the proposed diagnostic algorithm, which consisted of pre-processing step, followed by classification and detection using a hybrid deep learning framework. And finally, we have the final decision of the algorithm. So first of all, the image dataset are provided by Radiology Department from UKM Medical Center. And all these images are scanned by using Toshiba Aquilion 1 scanner. As you can see here, all the cross-sectional images that we use in the study are axial plane with these following parameters. Noted that we conduct several tests so that we can optimize the suitable parameter for this application. Okay, here I would like to show you an example of ischemic tissue in the posterior fossa region. As you can see here, as you can see here, this is the posterior fossa region which look like a butterfly. And you can realize here that it is very hard to visualize the difference between the normal and stroke lesion tissue in CT images. Thus, we propose a deep learning-based ischemic classification where we can use this to classify ischemic and normal PF slices that only display structure of interest. So during the study, we test several networks such as VGG16, GoogleNet, ResNet50, and Exception. So from the test result, we found that the Exception network provide a better classifier in terms of precision, specificity, and accuracy. So during the development of classification algorithm, we found that the CNN algorithm have various tuning parameters that can affect the classification performance to varying levels. So what we do is we conduct several tests to fine-tune the network by using Adam Optimizer. So in addition to that, we introduce dropout to remove the random probability of nerve code, which led the model into having more standardized learning feature while reducing the case of overfitting. Okay, and in the same time, we also integrate two convolutional layers and max pooling to increase visibility of target image features. So as you can see here, this is our proposed layer, which consists of dropout, two layer of convolutional layer, and max pooling layer. Okay. So from the experimental result, we found that among these two models, the improved exception model appeared to acquire the highest validation performance over the conventional exception model. Next, we also evaluate both model using 5-fold cross-validation, where 4-fold is under training and 1-fold for validation. Okay. From the result, it showed that the improved exception model achieved 99.58% average accuracy compared to the conventional method. And throughout this cross-validation test, it can be concluded that the visual representation learned by the improved exception model is appropriate to classify ischemic in posterior fossa region. So following that, we introduced deep learning to detect the ischemic in posterior fossa slices, in which a new hybrid of improved exception model and YOLO V2 detector is proposed. Okay, so despite the improvement offered by the YOLO network, we found that the outcome or the performance are very insufficient for the adoption of this application. So in view of that, we introduced YOLO V2 detector. So during the development, we found that several important key points need to be studied in details, which are first, the estimation of anchor boxes from the training data. The second one, the effect of different number detection of subnetwork. And finally, the importance of pooling layer in detection subnetwork. So here is our hybrid of improved exception model and YOLO V2 detector, which consists of two detection subnetwork. Okay. In here, we introduce down sampling method through max pooling layer to minimize the dimensionality of the features and simultaneously determine the appropriate features at each layer of the network. And in the same time, max pooling of 2x2 window filter size is integrated to avoid any loss of feature details, as filter with a large size can lead to a loss of information. So here, both detector models are evaluated with a validation dataset of ischemic in PF slices, as you can see in this table 4. And it was found that the high performance of true positive rate and intersection of over-union are achieved by the hybrid improved YOLO V2 with pooling layer. Okay, and we can observe the same pattern for the performance metric in testing data set. So finally, here is an example of the detection output where you can see our proposed algorithm have IOU of 85.94% with the ground truth. Okay, next we will move to our developed CAT system for PF stroke diagnosis. So as you can see here, for our CAT system architecture, there are two distinct components, which are front end and back end. Okay, so in here, the front end describe the presentation layer that comprise the graphical GUI, which communicate with first and second level of application. Meanwhile, the backend represent the data access layer, which support the front end and interfaces with any required resources. The backend process data from the database and send back to the front end. So here is our developed GUI for our CAT system, in which the user can straight away use it in single click. Okay, as you can see here, there are 4 main features, which are patient registration, pre-processing step, and here you have analysis button that based on the classification and detection algorithm. And finally, the user can make decision and reporting in our system. During our experimental study, it is noticeable that there are differences between senior radiologists and junior radiology trainee in terms of diagnosis report. This might be caused by lack of experience. So in practice, the junior radiology trainee may only identify the ischemic infarction if it appears visually enlarged and clear. However, most of the provided PF slices are presented with a subtle ischemic infarction that is sometimes can be missed by the radiologist during clinical interpretation. Therefore, this proposed CAT system has the potential to aid in the detection of ischemic in PF slices, such as subtle infarction. To summarize, the developed diagnostic algorithm has an enormous potential towards detecting ischemic in PF, in which it can provide detection rate up to 90.77%. And also, we found that the processing time for single image is 1 second per slice, and we can save the diagnosis time with proposed CAT system up to 39%. So from this presentation, I hope you have some general idea how can we implement deep learning in medical image analysis and CAT system. And finally, I would like to thank you all for your attention. Thank you.
Thank you to Professor Wanur Saswani for the presentation. This is an interesting presentation. As we know, deep learning topic become hot topic in computing today. Okay, we come into the Q&A session. To all participants, if you have any questions regarding the presentation of Professor Wanur Saswani, you can write to the chat box. Okay, is there any question?
I carried some questions from the participant. Yes, the system has been already implemented in testing level in UKM Medical Center in Kuala Lumpur.
Okay, you can go on, Professor Saswani. Okay,
Okay, I try to answer a question from the Sena Bayu Dewantra. He has 3 questions. So, first question is about the localization of the Sena Bayu Dewantra, the stroke itself. He has 3 questions. How I'm detecting the location of stroke before classification. Actually, we have a template or a ground truth that we get from the senior radiologist to identify it, and then we come up with the template, the real location of the stroke, and then we train our network so that it know that that is the location of the ischemic and hemorrhagic. So we use about 5,000 images for training and testing data. For training is 80% from 5,000 and testing is 20%. So yes, I did perform a pre-processing process before I feed in the images into CNN. And we also do annotation, some filtering in the processing step.
Okay, that is the answer from Professor
Okay.
Wander Saswani.
Can I answer another one?
Pardon me?
Can I answer another one from the chat?
You can proceed.
Okay. How fast is detection ischemic PF using CNN compared with manual? Actually, in manual, is very hard to identify ischemic in PF region. So normally, what they are doing in the hospital, we send this patient into MRI. Okay. So in here, with our system, we can process it 1 second per slice, and it might take in 5 minutes time to detect the ischemic of fossa using our system.
Okay, is that enough? Okay. The next question from Muhammad Rusli, Pak Muhammad Rusli.
Okay.
He asks, I think CNN method still need more big memory for its process. Is that really that CNN need big memory to process?
Yes. We need to use super host computer to train the CNN. And if you use the the usual computer, it will take ages to process all the data.
Okay, I think we have the time run up. Okay. We will end this session, the keynote speak session. I will thank to Professor Taufik, Professor Muhammad Asari, and Professor Wander Saswani for the presentation. And next, I will give the handle to the Master of Ceremony again. Thank you very much.
Thank you, Mr. Waru Jiriatno, for being the moderator for the activity today. And we would also like to say thank you to all our keynote speakers today who have given their ideas and knowledge, which is so insightful to all of us. Thank you. Now, we would like to commence the closing remarks from the head of Electrical Engineering Department of Universitas Brawijaya. So please welcome Professor Hadi Suyono. Professor Hadi Suyono, the time is yours.
Thank you, MC. Assalamu alaikum warahmatullahi wabarakatuh, and good morning. It is now my turn to make a final remarks of our keynote speech session in this morning. We have just finished listening and enlightening knowledge and expertise, sharing on the topic related to our conference teams, which is Powering Life in Society 5.0 through the development of sustainable engineering and technology. I do really believe that what we have learned from our keynote experts this morning would inspire us with many more ideas in engineering and technology for the dignity of humanity. Our immense appreciation and thanks are addressed to our distinguished keynote speakers, Professor Taufik, the Director of Electric Power Institute, California, Polytechnic State University, USA, and second, Professor Muhammad Asari, Director of Institute Teknologi 10 November, Indonesia, and the last one, Associate Professor Wan Nur Saswani Wan Zakaria from University Tun Hussein On. We also would like to thank all participants for having chosen the Axis 2020 as the platform to share their research result and contribution to the society. This conference is held every 2 years and organized in cooperation with the University Tun Hussein On Malaysia. But unfortunately, because of the pandemic COVID-19, this year we have no other choice but holding this conference virtually. Dependent on the quality of the communications signal become the main problem that very often cannot be avoided in achieving the success of the online presentation in virtual conference. We are deeply sorry for the inconvenience produced by this fact. However, we sincerely hope and invite all your participants again in Axis 2022. Before I let me MC continue to close the session, please let me announce some articles who have been chosen as the best paper under the suggestion of our reviewers committees. The first one is a paper entitled Doors Access Control Based on Illumination Invariant Face Recognition in Embedded System, to be presented by Bima Sena Bayu Dewantara from Polytechnic Elektronika Negeri Surabaya, Indonesia. The second one is a paper entitled Day-Ahead Joint Bidding, Strategy and Settlement Method of Charging Station, to be presented by Junji Ligao from Wuhan University, China. The third paper entitled is Statistical Analysis of EEG Pattern Comparison between Real Motion and Imagery Motion, to be presented by Haryani Ambarwati from Institut Teknologi Surabaya, November, Indonesia. The fourth article is entitled Design and Development of DC Light Bulb Using High Power LED, to be presented by Tri Nurwati from University Brawijaya, Indonesia. And then the last one is Performance Analysis of Hybrid Symmetrical Voltage Multiplier using Low Pass Filter, to be presented by Vicky Mudeng from Institut Teknologi Kalimantan, Indonesia. Congratulations to all the authors of the best paper, and we wish you all much more achievement in the future. The best paper certificate will be sent to you via email by the conference committee. Finally, on behalf of the Electrical Engineering Department, as the organizer of the Axis 2020, once again, I would like to thank all for allocating your precious time together in this plenary session, and I wish you all a fruitful conference Axis 2020. Thank you, and I give back the time to the MC to close the plenary session before we move to the parallel session. Wassalamu alaikum warahmatullahi wabarakatuh, and good morning.
Waalaikumsalam warahmatullahi.
Thank you, Professor Hadi Suyono, for the closing remarks. And once again, we would like to say congratulations to all participants who received the best papers. Congratulations. Next sessions for attendees, please prepare yourself for parallel session and please check your tentative schedule to see where your location room is. Now, before we get started, we would like to say thank you so much for your attendance and for your attention, for being here. And we do hope that we might get a chance to see each other again in the next Axis 2022. My name is Adriana Rimdrabayu. Thank you, see you, and have a nice day.
Prof. Asari, Dr. Wan dan Prof. Taufik, terima kasih. Jumpa lagi pada event yang lain. Terima kasih banyak.